Okay, so like I said in the last video, I'm going to now do a calculation where I'm converting moles into a volume. So what I'm looking at is a mole to volume calculation, or vice versa. Now, like I said in the other one where I was kind of messed up, it will only work for a gas. This relationship is only good for gases. So let's see. The gas we're going to use is I'm going to use carbon dioxide, CO2. And let's say that I give you, let's see, something like 0.3 moles of CO2. And I want you to figure out, sure, I'll come on writing down here, get rid of that. I want you to figure out what volume that amount of carbon dioxide is going to occupy. So the relationship that I'm going to use is that 1 mole of a gas is going to equal 22.4 liters. Now this is at a certain set condition, and the conditions happen to be 0 degrees Celsius and what's called 1 atmosphere pressure, which is sort of sea level pressure. Don't really worry yourself with that right now. We'll come back to it later. But what I do want you to focus on is this relationship right here, this equality. 1 mole of a gas. It turns out that it's any gas, which is really kind of an amazing little deal going on. But any gas, if I have a mole of it, is going to occupy 22.4 Nalgene bottles if it's at 0 degrees and 1 atmosphere. So again, what I'm going to do is I'm going to take what's given. The problem states that I have 0.3 moles, and now I want to get a conversion factor that's going to allow me to cancel out the moles. Well, the conversion factor that I want to use that will enable me to do that is to orient that equality that I just wrote up here in a way that puts the moles on the bottom, thereby the 22.4 liters goes on top. Now that 22.4 liters can also be decimeters cubed, because 1 decimeter cubed is equal to 1 liter. So that's, and you'll run into problems that go either way. So now all I've got to do is, all right, moles are going to cancel out. I know I'm good to go. I'm going to end up with liters as my answer, because liters is the last remaining unit that's showing, and it'll be 0.3 times 22.4. Okay, and I'm going to end up with, well, I really only have 1 sig fig, so I'm going to end up with 7 liters is going to be my answer. So 0.3 moles of CO2 is going to occupy 7 liters. I'm going to now do a problem, and I'll sort of start off the same way. Let's go to the next page. All right. Let's say I take that 7 liters of CO2. 7 liters of CO2. And I want to figure out, number 1, what the mass of that is going to be. Number 2, how many molecules it is. So number of molecules. Okay? Now these calculations are going to kind of take 2 steps. So I'm going to just kind of write them out, and you can kind of see hopefully what I did. Anytime I involve mass, anytime I involve mass, I'm going to have to figure out what the gram formula mass is. Okay, so when you're going to mass and moles, the GFM is what you need. So looking at the formula, carbon, there's 1 carbon, so that's going to be worth 12 grams. Whoops. Don't move. Okay. And I got 2 oxygens, so that's going to be 2 times 16 grams. Okay, so that'll be 12. This is going to be 32, and my gram formula mass for carbon dioxide is going to be 44 grams. So now what I'm going to do is I'm going to start off with what's given. The given amount was I'm kind of writing in a different position, and so I'm getting that some funny things showing up. So I'll try writing in a different way. So I'm going to start off with what's given. So I got my 7 liters of CO2. Now the first thing that I want to do is I need to convert this back into moles. So in order to do that, I look up and, okay, that relationship that I stated before where 1 mole is equal to 22.4 liters means that I want 22.4 liters on the bottom and I want 1 mole on the top. Because there is no direct way to go from liters to mass. I need to first go through moles. And that I showed that to you on that little flow chart in class, that you have to go to moles. It's in the center there. Now after that, what I'm going to end up with, the liters are going to cancel out. I'm now in moles. Once I'm in moles, it's not a big deal for me to go to the mass because I know that the gram formula mass of carbon dioxide is 44 grams for every 1 mole. The moles then are going to cancel out. My answer is going to be in grams. I'm going to take 7 and divide it by 22.4 and then multiply it by 44. What I'm going to end up with is 13.75, and I'm going to round that to 14 grams. So 7 liters of CO2 is going to have a mass of 14 grams. All right? Now, if I want to go to molecules, I'll try to do it here so you can see it on the same page. Again, I'm going to start off with what's given, the 7 liters of CO2. The first conversion factor has to get me back to moles. So it's exactly like the one in the previous problem. To convert liters to moles, I'm going to multiply it by 1 mole over 22.4 liters. Now this next step, though, I'm taking a different path. I'm trying to figure out how many molecules that represents. So that conversion factor is going to be 6.02 times 10 to the 23rd molecules. We'll just say that. I can't really write it. My pen's not that good. For every 1 mole. Now if you look at how the units cancel out, liters are going to be history. Moles are going to be history. The unit that is left is molecules. So now I know exactly what to do on my calculator. I am going to take 7, I'm going to multiply it by 1, which kind of is a silly thing to do, but I'm going to do it anyway. Divide it by 22.4, then multiply it by 6.02 to the 23rd, divided by 1 again, which you don't really have to do. And the long and the short of the thing is that I end up to 1 sig fig with an answer of 2 times 10 to the 23rd molecules. All right? So we're going to work on this.